In this episode of Things I Learned About Cloud Spanner, we look at choosing the right primary keys to help detect and avoid traffic jams during data load. Will we be able to clear the data highway congestion? Stay tuned to find out. So a while ago, my friend Anna approached me asking if I could give her advice on a database migration. Her online shop, Pile of Gadgets, selling toys like the Cloud Spanner fidget spinner, has grown tremendously, and she was worried to have the business running on the back of a traditional relational database. After watching the first episode of Things I Learned About Cloud Spanner, her team decided to explore and evaluate this new SQL database. They started from a recent backup of their database where all the data was exported to CSV files and uploaded to Google Cloud Storage. They then wrote a little loader program that was reading the files, processing them, and writing the data to Cloud Spanner. So far so good. Having the files in Google Cloud Storage and processing them from a GCE instance close to your Cloud Spanner instance is actually great. This way, you don't need to worry about network capacity or added latencies being an issue during your data load. However, while running their first data loads on a regional instance, there was some disappointment. They only saw a 35% utilization of their 3-node instance. Trying to increase the utilization by scaling out the loaders didn't help either. Now that was interesting. It looked like their load is hotspotting on only one node. 3 nodes, 35%? You do the math. To verify the assumption, they scaled the instance to 5 nodes and saw that the utilization dropped to around 20%, while the number of transactions and throughput stayed the same. And that was a clear indicator that only one of the nodes was doing work here, while the others... At this point, we needed to dig a little deeper and understand how Cloud Spanner organizes data to scale your workloads. Reading the documentation, you find that Cloud Spanner organizes rows in a table lexicographically, or for the mere mortals like me, alphabetically by the primary key. Then, driven by the size of your tables and load patterns, your data gets divided into chunks, so-called splits. These splits are distinct ranges of rows based on your primary key. To efficiently scale out all your reads and writes, each individual split can move freely between the available compute nodes, while making sure there is always, and I mean always, only one node that controls the writes to a split. Now that's where it gets tricky. If you write to a table with monotonically increasing or decreasing primary key values, like 1 to 3 or ABC, all your requests get sent to one split, the first or the last in your key space. And if you load many rows at once, you eventually exhaust the resources of your responsible node for that one split. Packed with this newly gained knowledge, we went back and took a look at the schema and data from Pile of Gadgets. It turned out that the application uses an auto-incremented integer for some of their primary keys, and the data was exported in that order, which is creating a hotspot during load by adding new rows always to the last split. To resolve this, they needed to modify the schema, such as introducing a distribution key that you prefix in your primary key, or using a well-distributed hash function to hash your existing key, or introduce an entirely new primary key that is well-distributed. With future scalability requirements in mind, they opted to generate a new UUID version 4 based primary key, and kept the old ID around for potential legacy purposes. After these modifications, they ran their data loads again and saw over time a full utilization of their Cloud Spanner instance, where the throughput scaled with the number of instance nodes. A little side note here. As you start to load an empty database, it will take some time for the first splits to occur and the load-based rebalancing to kick in. So it will take some time before you see the full utilization of your instance. So now my friend's company, Pile of Gadgets, was happy to continue their evaluation and see if they could improve the load performance even further. Unfortunately, we are out of time. To find out what we did next to maximize throughput during load, check out the next episode of Things I Learned About Cloud Spanner. And remember, choosing well-distributed primary keys sets you up for scalability. Last but not least, for the ones that love to dive into source code and run the experiments to learn more, check out the links in the descriptions.